Welcome back everyone to Learning by Teaching. Today we're in dynamics and we're going to solve problem 14.34, okay? It says, the spring bumper is used to arrest the motion of the 4-pound block, which is sliding toward it at a velocity equal to 9 feet per second. As shown, the spring is confined by the plate P and wall using cables so that its length is 1.5 feet. If the stiffness of the spring is K equals to 50 pounds per feet, determine the required unstretched length of the spring so that the plate is not displaced more than 0.2 feet. After the block collides into it, neglect friction, the mass of the plate and spring, and the energy lost between the plate and block during the collision. Alright, so the first thing that I like to do in order to solve this problem is first, let's write our givens. So we have that our weight is equal to 4 pounds, and from our weight we can calculate our mass. And we also know that the mass is going to be our weight divided by gravity. Okay, since we're in English units, it's 32.2. Then they're also giving us the initial velocity, so v1 is equal to 9 feet per second. We're given that the spring over here is a stretch because it's confined by this plate P. Okay, so that's really important assumption that we have to have into mind. Then we have the stiffness of the spring to be equal to 50 pounds per feet, and we cannot be displaced more than, so I'm going to put x equal to 0.2. This is our maximum displacement. Okay, so in order to solve this problem, well, we're going to utilize our chapter 14 equations, which were the principle of work and energy, and we're going to utilize the work of a spring force since we're working with a spring, so we will need these two. Okay, so let's start with the principle of work and energy. So we start with this equation where T1 is going to be equal to 1/2 the mass times the velocity, initial velocity squared. So we got 1/2 the mass, which we calculated up here to be 4/32.2 multiplied by the initial velocity squared, so 9 squared. Then we have to have plus the summatory of work. Well, the only thing that is doing work in this problem will be the spring, right? So let's go and draw a free body diagram at the time of the collision. So we have a small free body diagram. We will have our plate being pushed by our block VA. So this is when, therefore, we will have a force coming in this direction. Will be the force of the spring. Okay, we also have the weight. We have normal force. However, we're not displacing in the vertical direction. The only thing that is producing work in this case is the force of my spring. Okay, so with that, we're clear that we only need the force of the spring. Now, the force of the spring, we're going to follow these equations. So what do we have? We got negative, then we got 1/2 K, well, K is given as 50 by the problem, times the change of displacement of our spring. Okay, so let's take a look at this. Over here we got our system, and we're being told that the maximum that it can be displaced is 0.2 feet. So if we do that, we're going to have then from here to here is the maximum that it can be displaced, and this is a total of 1.3 feet, right? Which from here to here, there is a gap of 0.2. Okay, now the unstretched length of this spring is a little bit more than this 1.5 feet, and this one we don't know, and this is what we're trying to calculate. Well, it's the required unstretched length. Okay, so here we go back again to our equation. This is our displacement at point 2. Well, at point 2 we have this initial length S that we don't know minus 1.3, and we're talking about, if we we're talking about the displacement from our original all the way to our 1.3. And this should be equal to s minus 1.3 feet, okay? So that's for our final displacement. So we got s minus 1.3 squared. Then we have minus 1/2 k times the initial displacement. Well, the initial displacement is the one that we see here. Well, it's s minus 1.5. So you got s minus 1.5 feet squared. And this should be equal to T2, okay? So the next thing that we need to know is that T2 happens when our spring is at its maximum compression, meaning that it halted already our block A. Okay, so if I already halted our block A, our velocity at that specific point is equal to 0. Therefore, my right hand side will be equal to 0. So now all we got is one equation with one unknown. So let's start to simplify this equation. Let's simplify this first number, 1/2 4 over 32.2 times 9 squared. This will give me a total of 5.031. Then we have minus. I'm going to open a big bracket. If we multiply the 1/2 with 50, will give me 25. And then we have a difference in this is being squared. Therefore, this can be simplified as if we FOIL it out, we get s squared minus 2.6s plus 1.3 squared, which is equal to 1.69. Then we're going to have 1/2 times 50 is again 25, multiplied by s squared. So now we're foiling these two guys. Okay, so s squared minus 3s plus 2.25. And we close our bracket. This all should be equal to 0. Let's keep simplifying this problem. So we got 5.031 minus, and then we will have 25. So now we have to distribute the 25 with our parentheses. So we'll have 25s squared. Then we will have minus 25 multiplied by 2.6 will give me negative 65s. And we will have plus 42.25. Then we will have minus 25s squared for the second. So we are going to do the same, but with this parenthesis. Then we will have plus, because minus times minus will give me a positive 75s. And then we will have minus 56.25. We close our bracket, and all this should be equal to 0. Okay, so now the first thing that I can see is that this 25 cancels with this 25, and I'm going to distribute this minus throughout all my bracket. Okay, so we're going to have 5.031 plus 65s squared minus 42.25. Then we'll have minus 75s, and then we'll have plus 56.25, and all this is equal to 0. Now all we have to do is combine by terms. Let's combine our terms that has s. So we got positive 65 and negative 75. That will give me negative 10s. And then we can combine our numbers. We got positive 5 minus 42.25 plus 56.25. And this will give me a total of positive 19.031. And all this is equal to 0. So now we can solve for s. And s will be equal to 19.031 divided by divided by 10. And this is equal to 1.931, and the units should be in feet. Okay, so let's write the final answer now with significant figures, which should be around 1.90 feet, and this should be our final answer for our problem. So I hope you guys like the video. Please push the like button, subscribe, and I'll see you guys in the next one.